A good day to you all. I'd like to welcome you to my demonstration lesson. My name is Bothwell Riside, and with me here is a topic under a very broad topic in mathematics called trigonometry. And I'm going to be talking of how we can reach to the point of finding sine of 300 degrees. But because there are so many concepts before that children have to learn, or that as a student you must learn, I'm going to start by deriving how one can find sine of 60 degrees without using any table. Right. We are aware that whenever you want to find the sine of an angle, we say sine is opposite over hypotenuse and cosine is the adjacent over hypotenuse. Then the tangent is also opposite over adjacent. When I was at school, my teacher taught me this acronym, which I'm still aware of even up to today, cha, sho, ta, o. I'm not sure whether you are able to use it, but what we mean is for you to find the tangent, you say opposite over adjacent. For you to find the sine, you say opposite over hypotenuse. For you to find the cosine, you say adjacent over hypotenuse. So my teacher taught me this acronym, and even up to today, I remember it very well. Okay, I hope you're also going to be able to remember it. Now, the first thing that I want you to look at is you can draw a triangle. And what is the name of this triangle? It's an equilateral triangle, isn't it? It means that all sides are equal, and I've given each side of this triangle 2 units, 2 units, 2 units. So it's an equilateral triangle. And one of the characteristics of an equilateral triangle is that it is got all angles, they are 60 degrees in terms of size. So this angle is also 60 degrees. This one is also 60 degrees. Now, I'm going to do something very interesting here. I'm going to divide or draw a line that divides this shape into 2 congruent shapes. This line. If I draw this line, I'm going to have 2 triangles, and one is, both of them are right-angled triangles, isn't it? So I'm going to look at this triangle that I have here. Let me just quickly remove this. Okay, this is the triangle that I'm having here, which is an equilateral triangle, and I've divided it into 2 parts. What this means is that if this is 60 degrees, and after dividing this triangle into 2, this angle, since we said from here to there, the size of this angle is 60 degrees. So this one is going to be 30 degrees. And this is also going to be 30 degrees, isn't it? And this side is going to be 30 degrees. All right. One of this one is going to be 60 degrees again. But my concern is not on this triangle that is here, that I've shaded blue, but it is on this triangle, the new triangle that I have, a right angle triangle. So this one is a right angle. As we all know, sine, I'm going to be concentrating more on the sine rule, but I can talk of the tangent of an angle as well as the cosine of an angle, isn't it? Right, I want to establish what is the length of this side, which I don't know. If you know the Pythagoras theorem, it says that the hypotenuse, this one, to the power of 2 is equal to this side plus this side to the power of 2 plus this side to the power of 2. So since I have bisected this line, this side is going to be 1 because from here to there, it's 2 units. So this is going to be 1 unit. So I'm going to say this side plus to the power of 2 plus this side to the power of 2. So I'm going to have 1 squared plus unknown side. What should I call it? Let me say y squared, isn't it? This side, we don't know how many units it is, but from this Pythagoras theorem, we can now say, let's put the like terms on their own. Then we're going to say y squared to find this side is going to be equal to, we know this, you have done Pythagoras theorem in the lower classes already. So y squared is going to be equal to 2 squared minus 1 squared. So I'm going to find out that the square root of, this is 4 minus 1, square root of 3 is the value of y. So this side is square root of 3, isn't it? Don't bother yourself looking for what the root of 3 is. I just want to derive a formula here. Now, given this, we are now able to establish what is sine 60 degrees. You know, how do we do sine? How do we find the sine of an angle? Sine theta is equal to, let me just erase this. So we now know that that side is root of 3. So sine of an angle is equal to the sine of an angle. Sine theta is equal to opposite over hypotenuse. The opposite is this one over the hypotenuse is root is 2. So I'm going to say, which is equal to sine 60 degrees, sorry. Sine 60 degrees is equal to opposite over hypotenuse. The opposite is 3, root of 3 over 2. If you want, you can now prove this, use your calculator and check whether root of 3 over 2 as a result will give you sine of 60 degrees, isn't it? Right. Now, we now know what is sine of 60 degrees. I can even find sine of cosine of 60 degrees. I can find cosine of 60 degrees is adjacent over hypotenuse. This is at the adjacent 1 over 2, which is half or 0.5. Check it in your from your calculators. This 1 over 2. I can even find the tan of an angle 60 degrees. I will say it's equal to, what is it? Tan is, we find it by saying opposite over adjacent. The opposite is this root of 3 over the adjacent 1, isn't it? Which is any number divided by 1, it will still give you the same number. So the answer is root of 3. All right. I think you have understood now how we can find sine of an angle of which is 60 degrees without using our calculators, isn't it? Right, we can try find it, use your calculators, try to find sine 60 degrees first, then put your number aside, then you cos 60 degrees, put your number aside, then you say tan 60 degrees again, you put your number aside. After doing that, I want you also to find whether 1 over 2 is quite clear and the answer is 0.5. So this one, you quickly find it. Then find what is the value of root of 3. Is it equivalent to tan 60 degrees? What of the value of root of 3 over 2? Is it equivalent to sine 60 degrees? But okay, so if you found it to be like that, that's so good. Now, I want you to look at what we mean by quadrants and so forth. The first thing that I have to know is that we don't just find the ratios or trig ratios of angles that are less than 90 degrees. We can find, for example, sine of an angle that is like 95 degrees, 150 degrees, 200 degrees, 360 degrees, 700 degrees. We can also find that those kind of angles. But today I want us to look at how we can find sine 300 degrees, isn't it? Right. In mathematics, we talk of these quadrants. I know we might have done this before, and we know that here, all our angles are positive. So sine of any angle, if an angle is less than 90 degrees, when an angle is from 0 to 90 degrees, it means its sine, its cos, its tan is positive. Understood? Then, when an angle, usually this is the first quadrant, and then we go to the second quadrant, then this is the third, and this is the fourth quadrant. Quad, the word quad means four, isn't it? So we have divided our angles the complete rotation into four parts. Now, when an angle is more than 90 degrees, I'm going to write the acronym that I was taught by my teacher again when I was at school. He used to say XACTS. It's very easy, it's very easy. Or he used to say cast, CAST. Right. Now, I want you to know that in the second quadrant, all angles of sine are positive. The rest are negative, isn't it? So if I say sine 96 degrees, it's positive. But if I say cosine 96 degrees, you're going to find a negative number. I want you to try that. Find cosine, cosine 75 degrees. Find sine 75 degrees and tan 75 degrees. You're going to see that tan and cosine will give you negative numbers. Okay, so in the third quadrant, if you want to find sine and cosine of the numbers, they are all negative. They're both negative, but only the tan is positive, isn't it? In the third quadrant. Then in the fourth quadrant, it's only the cosine, which is positive. Is that understood? All right, so let's say you want to find the sine of sine 300 degrees. The first thing that we have to do is to establish in which quadrant is sine 300 degrees. Right, we said from here, all angles are measured from this zero here. They go to anti-clockwise direction, in the anti-clockwise direction. So from here, we have 180. If we add another 90, we'll get 270. Is that okay? And then from 270, if we add another 90, we'll get 360, which means our sine 300 degrees is in the fourth quadrant. When definitely the sine of 300 degrees is negative, because in the fourth quadrant, it is only the cosine which is positive. Is that okay? Are you understanding me? Now, I'm going to sketch or do a sketch of this 300 degrees angle. The 300 degrees angle is somewhere closer to 270, but it's a little bit far from 360. So I'm going to put my angle as being somewhere here. Right, all the angles that we are talking about, we are measuring them from here. We are measuring them from here. So this is where my 60 degrees is going to be, isn't it? Right. We are measuring them from here, and this is what we do. So what I'm saying here is, from here coming to this, there are 300 degrees. So my angle is this one, which is 60 degrees, this one. We measure all angles from here, from this line. Even if I was going to look at an angle like, what can I think of? 200 and 180 minus 6 is 120 degrees. Sine 120 degrees. I was going to say 120 from here to there is 120. The angle is this one. So all angles are measured from this line. Are we together? So here I have 60 degrees that are left in order for me to get to 360. So I'm left with 60 degrees. So I'm going to find the sine of 60 degrees. We are all aware that whatever that we're going to get is going to be negative, which means sine, already we know that sine of 60 degrees, from what we have been doing before, sine of 60 degrees is equal to root of 3 over 2, isn't it? Someone is just getting confused here, I know, but how are we now talking of sine 60 degrees when the angle is 300? Now, let me repeat myself. From here, from 0 to 9, we have got 90, 270, 180, then 270. Then here we now have 300 degrees. This is the line. This is where the angle is. Our angle is this one. The sine of 300 degrees is this angle. Are we together? So we are going to say sine of 60 degrees is root of 3 over 2. But remember that it's only the cosine that is positive in the fourth quadrant. Meaning to say this one is going to be negative. Therefore, my answer for sine 60 degrees, for sine 300 degrees is minus root of 3 over 2. Right, this is my answer. Thank you very much. I can even look for cos 60 degrees and tan 60 degrees. Let me try to do it again, just for interest's sake. If you want to find the cosine of 60 degrees, not 60 degrees as such, I want to find the cosine of 300 degrees. I'm going to go to this angle again. This is where my 300 degree angle is. And for me to get to this is what I'm talking about. This is the angle that I'm talking about. For me to get to 360 or to the 0 degree line, to this horizontal line, I'm left with 60 degrees. So I'm going to look for cos 60 degrees. Cos 60 degrees is 1 over 2. And what it means is that here our cosine is positive. Therefore, cos 300 degrees is equal to 1 over 2. Is that okay? Because we said our cosine in the fourth quadrant is positive. Let's go to the tan. The same thing, this is the tan. Tan theta or tan of x, tan of this angle, is like saying tan of 60 degrees. Tan 60 degrees is root of 3. Please remember, this is the fourth quadrant. In the fourth quadrant, it's only the cosine that is positive. The tan is negative. Therefore, tan 60 degrees or tan 300 degrees, let me say tan 300 degrees is equal to negative root of 3. That's the answer. Is that okay? Thank you very much. Next time we're going to be looking at angles like sine of 45 degrees, cos 45 degrees, and so forth. You're going to see also how interesting it may be. We can even also find the sine 30 degrees, cos 30, and tan 30 degrees also. We can find it again. Thank you very much, boys and girls. I hope you have enjoyed the lesson, and let's try and work out some problems that I'm going to be giving you. Thank you very much. Goodbye, good children. Bye-bye.